Good evening, everybody. So I am Yelena. I'm one of the teaching assistants in data analytics program. So the purpose of tonight's meeting is a help session on a big SQL assignment. So and this meeting is being recorded. So now here is the agenda for tonight, and I'm gonna walk through an example, and I'm gonna show you the statement of work. And then we're going to do the create table statements. We're going to do the insert statements to insert data. And we'll talk a little bit about the queries, views, and I'll show you how to do the queries against the view. And we're going to do the question and answers, right? So let's continue. So what is the statement of work? The statement of work explains the business purpose of my problem, right? So, for example, as an example, I want to track the database for university that will facilitate the advisors to analyze the students' academic performance. So, I want to track in my database, I want to track the student ID, student gender, and the year when a student was admitted to the academic program. And I want to track the number of credits that each student fulfilled toward requirements. And at the same time, I'm going to have a course, and I want to track the course code and the course title, and the number of credits that the student will earn upon successful completion of the course, and the course durations, right, in the weeks. So now I keep on defining my business rules, and I can say that each student may have completed none or many courses. Each course may have been completed by 0 or more students, right? So this is my business rule. And now, so I've got the students, right? And I've got the course. Each student can take more than one course, and each course can be taken by more than one student. So what do we have? We have a many-to-many relationship, right? So to solve it, I'm going to have another entity or another table, and I'm going to call it enrollment, right? So enrollment will have the course key, the student ID, right? And in addition, I'm going to track the grade that the student earned in the course, and I'm going to track how many class meetings the student missed, and I'm going to track the enrollment year and enrollment semester, right? So this is what I'm going to do. And now, see, here is the statement of work. I underlined my entities purposely, right? So I have student, I have course, and I have enrollment. Now, the properties such as the student admission year, academic program, gender, and number of credits, those are called the attributes of a student, right? Because this applies to the student. It does not describe the course. It doesn't describe the enrollment, it describes the student, right? So now what I did, the next step is I did the entity relationship diagram. You're not required for this assignment, but I thought I'll do it so that way it will help you understand a little bit and it'll help you follow the rest of the demo. So here it is. So as I mentioned earlier, my entities are the student, and course and enrollment, right? So I have student, course, enrollment. This is the diagram. So now I have one-to-many relationship between student and enrollment because a student can be enrolled in more than one course, right? We are tracking in here all the coursework the student completed up to today. And here I've got the course. And you can have more than one student who took the same course, right? So many-to-many relationship is resolved by associative entity. And of course, enrollment is going to have a student ID and a course ID foreign keys, right? So each student is identified uniquely by the student key. That's called the primary key. And I have an enrollment key, and I have the course key, right? So this is a unique identifier. Every course has its own unique number, right? Now, next slide is the primary key rules. So now, this is very important. Each entity, right, that will track the data about must have a primary key. A primary key is going to identify each instance of an entity uniquely. Like, for example, if Yelena is a student, Yelena is going to have a unique student ID. Now we have another student, Bianca, for instance, right? She's going to have her student ID. We have Jerry, he's going to have his student ID, right? Everybody is going to have unique. Now, we cannot have a student without an ID. That's what it means. Cannot be null. It means that the value cannot be empty. Everybody must have an ID. And keep this in mind, that the primary key has to be, it's better to have a single attribute, and it has to be numeric, and it has to be something that does not change over time, right? For example, name is not a good choice for the key. Why? Because names are subject to change, and there could be someone else with the same name, right? Now, something else to keep in mind, you want to make sure that your primary key is security compliant. So you don't want it to be the password number, and you don't want it to be the security number. Because guess what's going to happen? Take a look at this. If I use over here the social security number as a student primary key, the social security will show up in enrollment table as a foreign key, right? So my social security will show up all over the place wherever the student ID is a foreign key. So that's a security violation, right? So never use the social security number, password number, and the credit card number. Don't use it as a primary key, right? So this is very important. So now what we need to do here, I defined my business rules. I defined what my entities are, right? Every entity will become a table, right? So here in a big SQL, I'm going to have 3 tables. I'm going to have to write the create table statement for the course, for the student, and for an enrollment. Very important here. Which table do I create first? I need to create the student and course before I create an enrollment. It's because we cannot have an enrollment record for a student who does not exist. And a student cannot take a class that does not exist in a course catalog, right? So here we have a parent table and child table relationship. Student table is going to be called a parent table. And an enrollment table is going to be called a child table, because the enrollment table will have a student key, which is a foreign key referencing the primary key in the student table. And it's going to have another foreign key, course key, referencing the primary key in the course table, right? So that's a foreign key. One thing I wanted to point out, that was the reason you are not explicitly asked to add the constraints to the code of the assignment, is because the keys, the constraints are not actually enforced, and I'm going to show you what I mean. They are there, you can create them, but they're not enforced in a database, right? So they're just conceptual. And now, well, I'm going to show you how to create the tables, but here that's what I want you to keep in mind. In your script, the order of statements is very important. At the top of the script, you want to put the drop table statements. And I'm going to be sharing my screen with you shortly, and I'll show you a script that I wrote for this example database, and you'll have a copy of the script when you get the video recording. So at the very top, I have to have the drop table statements. It's because I'm going to be running my code more than once. As I'm working on it, I'll be running it more than once. And the idea is to recreate the database when I make change. So you have drop table statement, and you're going to create all your tables. And then I'm going to show you how to validate if the tables were created as expected. Then you're going to have your insert statements. Then you're going to have a command commit. Basically, when you run an insert statements, the data is not inserted in a table right away. It's in a buffer. So the commit command writes the contents of the buffer in a table, right? So what you have to do is you need to follow the order, right? We don't mix the create table statements with insert statements because there is a risk of locking the tables. Trust me, every semester I had a student who would create a table lock. And if that happens, you would need to wait for about half an hour to an hour for the lock to expire. Or another option, you would need to create table with a different name. Now, see that you have insert statements and you have commit, then you're going to have something to validate that insert statement worked. And then you're going to do the queries, and then you're going to create a view, and also you're going to write some queries against the view to select data from the view, right? So, now, here I'm going over it again, the order of create table statements, and it's going to make sense when we look at the script. We're going to put the drop table statements at the top. The order of the drop table statements matters because if you look at it over here, here are my relationships, right? Rather, I should be looking at the diagram. Here it is. So basically, I cannot delete the student while I'll still have a student's enrollment record, right? I cannot delete the student, or at least without deleting the corresponding enrollment record. It's because of the foreign key, right? So when I want to drop my tables, I have to drop enrollment first, and then student, and then the course. So the order of drop table statements matters, and so is insert statements. We want to populate the student, the course, and then enrollment. Now, student course, it does not matter which table you do first, because there is no relationship between those two. They're related to enrollment, right? But enrollment gets dropped first, created last, okay? So that's something for you to keep in mind. And basically, I summarized some important guidelines here. And here, basically, the order of drop table statements is usually reverse of the order of create table statements. Now, today, one of you, guys, if you're not speaking, please make sure you put yourself on mute. Okay, now, one of you today pointed out that I have to mute all. All right. So some of you, one of you pointed out today that when you ran the script for the part 1, for the first time when you ran it, I think it was Bahan, yes, Bahan, I think you pointed it out today that when you ran the script that I gave you, right, for the first assignment, for the first part of the assignment, you received an error message when you ran the drop table statement, yes. And the reason you received it because the table did not exist. Excellent, I'm so glad you pointed that out. Okay, you received that error message because the table did not exist in a system, and when you ran my script for the first time, and this is expected, so don't worry. Now we're gonna get here. When we get here, let me share my screen, and I'm going to get to hands-on part. Now everybody, please make sure that you are on mute. All right. So now what I'm gonna do is I'm going to do share, and I'm gonna share my screen, and we're gonna get into big SQL. So now here is my application, and what I need to do is I need to click on this tile to launch big SQL. Okay, guys, please, if you are not speaking, put yourself on mute. There we go. And now we need to be patient for it to launch. And when it's launching, in the upper right corner, this is your username. The username that you use to log into the database. Okay, and that might be, okay, there we go, it's coming up. So, while it's coming up, I need to tell you that if you notice it's retiled, right? We're gonna use the big SQL in this class, but in general, if it was working, you could import your data into the big sheets and do some analysis with that. So now, guys, I hear some echo, so would you please put yourself on mute if you're not speaking? All right. So here it is. So right now, I logged into the big SQL, and right now I'm in a SQL editor. Okay. So I'm in a SQL editor right now, and what I need to do is I need to connect to the database. To do that, I click over here, right, and I'm going to select my database, and it's going to be big SQL. Immediately, that thing pops up, and I have to put my login name, right, and my login name is this, and my password, I put it in a text file. Control C, and then Control V, okay. Now I'm gonna click OK, and I'm gonna be connected to the database. Now, minimize. So what I did was I prepared the script ahead of time, and remember that we never use Microsoft Word for the script. Notepad is okay. The TextPad is good too, and also Notepad++. That one is, you can download it for free. And I'm not really sure. I'm not really familiar much with Mac, but I'm sure there are not rich text editors, right? You don't use anything that rich text formatting such as WordPad and Microsoft Word, because it gets corrupted, especially the quotes. See this quote here? And it's totally different than the quote, single quote from Microsoft Word. So the quotes are infamous for corrupting. Now let me do this. Let me copy and paste only the DDL part. So this is called the DDL, data definition language. That's create table statements and the drop table statements. This is called the data definition language of the database, right? So now I'm gonna copy and paste here. And the nice thing is that it's highlighting the resort words for me. The word drop is a resort word. So I cannot have a table name called drop because this word is a keyword. This is reserved by the Oracle, or I'm sorry, by the database. I keep thinking of Oracle because that's what I work with usually. All right, so here it is, drop, right? And here is what we drop, table. And this is a table name, enrollment. And remember, each statement has to end with a semicolon. So at the top of my script, I have 3 drop table statements. Now remember, I have to drop the enrollment first, right? And I drop it first because if I drop the student first, what's going to happen to enrollment records, right? In theory, most of the databases would give me an error if the constraint is enforced. So let me minimize this. All right. Oops. Okay, here we go. So now I'm going to create the first table, student, right? Create Hadoop table if not exists. The reason I put if not exists is because if the table already exists, it's going to ignore it. My statement will be ignored. I'm not going to get an error, but at the same time, it's not going to execute. Now, what I'm doing here is that the first column, I call it student key. Data type is integer, and I put it not null. Not null means that when I insert data, I cannot insert a blank into the student key. I must insert a value, right? Gender, and I want to define the business rule here. I want to the only valid values for my gender would be male and female, and I want to store as that uppercase M and uppercase F, perhaps, right? I want to store it like this. Also, in big SQL, the constraints are not enforced. In general, this is how you would do it. At the end, right, after the last field, you put the word constraint, and here is the constraint name. Here is a constraint type, which is check, and here I'm specifying the condition. Here, basically, I say that I want my gender to be either male or female, but nothing else, right? This is basically one way to just define the business rules. Again, you're not asked to do that in assignment because the constraints are not enforced, but I think that could be very valuable for you to know, right? And this is something I could mention in the last section in the summary, that it would have been helpful to have this functionality, right? So here it is. This is my first table, and here's my second table, right? The course and the student. And my third table is enrollment. And here I have more constraints. So here, this is the primary key, right? And here is a foreign key constraint. And what I'm saying is constraint, and this is a constraint name, foreign key. And the constraint is defined on this column. References, here I put the table name. And this is a column name in the parent table. So here the table with the foreign key is called child table, and the table that the child table is referencing is called the parent table. Right, so this is a little bit of the terminology. Now let's go ahead and run this part. I'm gonna hit run. Success. Okay, good. But whenever you get in an error, you want to click here to expand and see the actual message. In this case, the query ran successfully. That's what it means, right? So that means I expect all my tables to be created as expected, right? And there is more than one way to verify that the tables were created. And one way to do that, you can go to the, see this right now, I'm in the SQL editor, and I can go to explore databases. Now, while I'm on that screen, I'm going to see, for some reason, it's going to show me all tables in the system. But that's not what I'm interested in. Well, hold on. From here, I'm going to select my database, which is Big SQL. And now I'm going to, well, all right. It's good that I got this error. You can just click OK and ignore. Here, I want to select Hadoop tables. And now what I'm going to do, I'm going to go to the defined filters. Watch what I'm going to do. I'm going to set a rule, and I'm going to put schema. And here I'm going to put my username. And the reason I do that is because I want to list my tables. Schema is a user who created the table. So I want to see the table that I just created. So here it is, I put schema, contains. Well, basically, if I am not sure how to do the correct spelling, but I know that my username contains this string, I can search like this, and I'm going to hit filter. So now I'm going to see the tables only that I created, right? So remember, if you filter it, you're going to see the tables, Hadoop tables that you created. So here is the table name, and this is the schema, right, which is you. The date when you created the table, and the access time. That's probably how long the command took to run. Well, I'm not quite sure about this, but here it tells me that I have 8 tables in my schema right now, and 0 selected, but if to select it, just click, right? Now, let me go ahead and click here, and I'll show you what information you get. So here is a course table. Here you get the table schema, and here is just more information on the table properties, when the table was created. Now I can click on the columns, and it's going to give me the property of the table columns, like course key, course code, and so on, right? So that's basically telling me the table structure. I'm not going to look at and go into the privileges, but in general, what I could do is I could grant specific right to Lineage, for instance, to allow select data from my table. Or I could grant another access to Jerry to let him select data from my table and to let him update my data. I'm just giving an example, right? Now what you could further do, you could also click on the columns and see the column property, just to drill down and check the properties. See this? It says it's primary key, but it's not. Unfortunately, it's not enforced. If you see it, yeah. Anyways, it's not enforced, so something to keep in mind. And nullable means that you cannot insert the empty value. You have to specify the value when you do insert statements. And I will show you how the better way to do insert statements. I'll show it to you. We'll get there. So now there is another way to do this. Let me go back to the SQL editor, because you're not always going to have the nice interface like this, right? So now I saved this code in a text file, so I can just go ahead and delete all of this, right? I just do select all, Control A, and just hit delete key. Now what I'll do is I'm gonna go back to my code, and I'll show you this command in here. This command right here, and I'm gonna give you a copy of the code afterwards. So this command is another way to see the table that you created. This is a data dictionary table, and it's going to store the information on tables for all users. But since I'm not interested to see what someone else created, I'm gonna put the condition in here. I'm gonna say where table schema equals, and here is my username. But notice that username has to be in the uppercase, because this is all metadata, right? Data about tables is stored in the uppercase. So now let me go and run this here. Successful. So now I want to see the actual output, and you can adjust this. See this? You can drag this. Now here, this is another way to see that the table was created. Okay, so here it is, table schema, which is my username, right? And here is a table name, and this is saying just the corresponding Hive table, right? And here is an owner, big SQL, that's probably the database name in this case. No? So here it is, this is my information about the table itself. And here I can just look at I can just download the history. That's nice. Huh. Isn't it that neat? You can download all the commands and output this way. And so if you click on this download history, you will be able to get the statement that you ran and the output. That's neat. So for you, it's probably going to open in a notepad, right? It depends on the editor on your system. Now, I'm going to show you something else. You can also get the information on the columns. So this is another query right here. It's called hcat columns. So this is a system catalog. And if you're working with other databases such as Oracle, they also have these catalogs, which I find it really useful, because sometimes you may not know the exact spelling of the table, so you can run the query. For instance, I want to list all tables that start with ST, for instance, right? If I'm not sure about the correct spelling. And if I have thousands of tables, and it's very laborious to go through the whole list one at a time and to search, right? So I can run the query, and it makes it very simple, right? So here it is. Now what I did was I ran the query against this data dictionary, hcat columns, and it's listing me my schema name, my table name, and it's supposed to list the table columns. It's supposed to list the table columns. Oh yeah, because I have to scroll. Yeah, but I'm supposed to see more details. Yeah. See this? Like, for example, this is my other table, the customer. I have a city, I have a street, and I have first name, last name, right? So what I could do is I could eliminate this further. I could say and tab name equals location, right? Notice this is a where clause right here, and I put another condition, right? So I want the schema to be my username, right? My schema, and I want the table to be location. I'm just giving you an example. Here it is. So I modified my query because I want to see just one table, right? So that's what you can do. I'm just showing you the ideas. So basically, to verify that the tables have been created successfully, you can just go ahead. You can check the data dictionary view, right? And the data dictionary hcode tables and hcode columns, and you're gonna have a copy of this. So that's one way. Another way was that I showed you that screen, the database Explore databases screen. But you also want to know how to do it programmatically because you're not always going to have a nice interface, right? So now what we're going to do is we're going to work on inserting data. We have to insert data into the parent tables first, into the student tables, right? And the way I recommend you to do it is you list your columns here. Although the columns names is optional if you inserting data into all columns, the listing the columns is optional, but the problem is we don't know the order, right? We want to make sure, we want to pay attention to the data types, right? Like for example, if the student key is a numeric, we don't want to insert data analytics in there, right? If this is a year, right? 2006. We don't want to insert, or 2016. We don't want this to be inserted in the number of credits the student completed. Nobody's completed 2016 credits. It's just impossible unless one course is 100 credits. it's not realistic, right? So to make sure that you are inserting the correct value into correct column, you want to list the column, and underneath you list the corresponding values. And to be honest, from experience, the insert statement is the most challenging part of the database projects. All right, so now what we're going to do, I'm going to copy this code, and this is only for the student table. I'm going to copy this code and I'm going to paste it in the editor. And I'm going to go back here. Okay, I'll paste it here. And now I'm going to run it. And what do I expect? Here, something else to keep in mind. One insert statement inserts only one row. So to insert 6 rows, I have to write 6 insert statements. That's just how it is. I cannot insert all rows in a single statement unless I'm doing a loader. Some databases support loading the data from a large file, something that you have seen before in the DB, right? But in this case, I'm just running the insert statements. So I have to explicitly spell out the column names, and I have to list the values. So now let me go ahead and run it. Notice that insert statements take some time to run, right? But guess what? Where did it get written? It got written to the buffer, right? Because I have to do what? I have to commit. Now let me type commit. Let's commit, right? And now if I want to run just one command, I have to highlight it. I have to highlight it and click run, right? And it's successful. Now, how do I know that the data got actually inserted into the student table? So what I could do is I could do this select count star, right? Star from student, right? Now, here is a query, something for you to remember. Every query must have at least select and from. This is non-negotiable, right? So each query must have select and from. You cannot have a query without select, and you cannot have a query without from. Just non-negotiable. Now let me go ahead and run this. I have to highlight this. Right? Run. Running. Here we go. So here it returned the number of rows. It's expected. It's 6. Okay? But notice right here, it named the column as 1 for me. It's because, well, I'm doing select count star, but I never specify how I want to name this output column, right? It names it for me, and 1 comes from the position. It's a position of the column in a select clause. It just named 1 for me. But what I want to do is, and I want to put number of students. This is called the alias. Right? This is called an alias, and I'll show you what it does. Run. There we go. So instead of writing down 1, it showed me that number of students. So basically, this is what I want to display. And the behavior is different. In some databases, it would show just count star, and here it just shows 1. All right? So this is very important. Now, I only inserted data into my student table. If I go ahead and if I change this to course, let's see what's going to happen. What do I expect to get? I think I expect to get 0, right? And here I'm going to say number of courses. I expect to get 0 because I have not run my insert statement yet, right? Oops. This is what I did. I should have highlighted this because I want to run only this statement. You have to highlight it before you hit the run button. Now, but let me show you something else if what already happened. In theory, I should have received an error. I should have received an error message because I already have a student with student key equals 1, right? So in theory, I should have received an error message because my student ID is a primary key. I cannot have more than one student with the same student ID, but instead, the query ran successfully. It's unexpected result, right? I got something that I did not expect. All right, well, how do we undo this? I can go ahead and drop all the tables, but instead, I can also write the delete statement. Right? Delete. And I think it's like this from student. Right? But basically what I want to do is I want to delete. Oops, it failed. Whenever you get an error, you want to click here and it's gonna give you the error message, right? So my delete statement is wrong. I would have to look up the syntax, right? Let's see. If you click on syntax assistant, this is only for the SQL, right? So just keep it in mind. It's only for the SQL. So we're not going to want to do that, right? So now let's close out of this. Cancel. All right. So I would not recommend you using the, I do not recommend you using the syntax assistant because this interface, it does not work in all browsers, okay? It does not work in all browsers. All right. Now, let's do this. Let me take the whole script and rerun it again. Right? So let's do this. Let's do control. Let's do this. Let's copy it up to the end of insert statements and the commit, right? I should have, okay, here it is. Insert, and up to the commit. Here it is. Control C, Control V. I'll show you what's going to happen. Now, first I'm going to run commit just in case. It's because I did some insertions. I do not want any problems. So basically, if I run an insert statement and don't commit, and then immediately when I try to drop the table, I'm going to have problem because the process that inserts data still has a lock on the table. right? The process grabs the table log. And to drop the table, another process tries to get the log. So here it is, you created that log. And since here I do not have database administrator privileges to find which table is locked and to unlock, we have some options. You would need to either rename the table or wait for the lock to expire on its own, right? So now let me rerun this script again. Run. I believe it's delete from and then table name. Yeah, but anyhow, let's do this. Okay, so syntax is different in each database, but what's important is that in understanding the concept, because if I'm not sure what the syntax is, I can always go to my knowledge base and I can look it up. See this? The delete and update, right? So here it is. I can just go in and I can just look up my syntax. There we go. See this? If I need to. So most important is understanding the concept. So now here I created my tables and my tables have data. What do I do next? I can run queries, right? So let's delete everything and I'm gonna pick up my first query and here it is. So here and in the paper I would have to explain the business purpose. I want to display the student and I want to display the student average grade. So that's basically the query is gonna help me see the academic standing of my student, right? So I can run this statement, and it's gonna show me my students, and here it's gonna do the average, right? That's what it did. It took for each student in enrollment table, it's basically computing the averages. Here it is, right? That's basically just the average. And by default, it's showing me the first 10 rows per page, right? Oh, 6, yes, okay. 6 rows, that's right. So here is a default. If I have more than 10 rows, my data would be broken into pages. By default is 10, but I can change it, right? So here it is. And of course, I can always filter data here, but the problem is I want my work to be reproducible. So if I go here and if I define the filter, for instance, student key, and I wanted to say is less than 5 filter, I'm able to apply my filter, but the problem is it's not going to be applied in the query. And if I click here to see what statement I ran, right? Oh, the query is pasted here, but there's no where clause, right? There's just no where clause. Here, clicking on the data link, it's just gonna download the output. And in this case, it's okay because it's your data. There is no license violation issue here because the data is yours. And here, this is a download history. It will just show it's just a log. It shows that the query ran successfully, but notice here, it does not reflect the filter that I did, right? It does not reflect this. And here you can also decide which columns you show hide, but it's not going to be reflected in the query, so that's a problem. Now, group by. The reason you do group by is because I want to see the average per student. And as a rule of thumb, remember this, whenever you have an aggregation function, as a count or average or sum, any column that you display besides the average has to be listed in a group by clause. Otherwise, you're going to get an error. See what's going to happen. You're going to get an error message, right? So whenever I list something here, right, it's going to give me an error. Because I have to have the column that I list here, it must be in a group by. It's just something you need to remember. Right, there we go. Now I can further apply a filter to this. I can say, okay, I want to see a student with an average grade above 90. Now, what am I going to do? I'm not going to use the where clause. You know why? That's a difference. The difference between where clause filters individual students. The having clause rather filters the group, right? So here, I have to put the having, right? Having average grade, right? Greater than 90. Remember, this is not a where clause. This has to be in a having clause because this is basically the grouping. We are not looking at individual student record, we're looking at the average grade. So I want to see only students whose average grade is greater than 90. This is a having clause of a query. So we have select, from, where, group by, having, and order by. Order by is for sorting. So now let me run this. And this worked, and it's going to show me only the students who got an average above 95. And you can actually sometimes you write the queries to verify your work. For instance, I could look at specific student 4 and I can query my database to see what grade student 4 has and then compute an average, right? And see if the average is greater than 90. Well, sometimes you have to write queries to validate the queries. So that's something to remember too, right? So this one, I'm going to go ahead and I'll save this because later you will have a copy of the script. So let me do this. Let me save this. Right? So now here I have more advanced queries. This is more advanced. Let me copy this. And I'm going to paste this here. So now here, what this is going to do is, in addition to displaying the average grade, here it's going to display the average grade in the course, but it's also going to show me how many people took the course. And I have to group by the course key because the counts are for the course, right? So here I'm running the first query, and this is the second. I'll go over it in a few. So here I'm doing the average and the number of students who took the course, right? But, well, it's not really very helpful because I don't have information on a course name, right? So to do that, I would have to join the course, right? So let's go ahead and steal this statement. Let's steal it from here. Control C. Now, let me show you something. Since here, I'm going to have two tables, right? You have to put a table alias. And the reason is, I have some columns. Some of my columns, like course key, may appear in more than one table. So the database needs to know which table I'm pulling it from. So here it is, right? And I'm going to prefix my column name with a table name, right? With the alias. So this one, I'm pulling it from enrollment, right? This one, I'm pulling from enrollment, e.average. And here, and this is the alias. I want to call it course average, and this is number of students, right? So I want to prefix this with e. Well, in this specific case, it might not be necessary because the grade appears only in enrollment, but the problem is, at any time, there is a chance that you're going to be adding another table anytime, right? So now what I want to do is, I want to add the course code and the course title, right? But I want to show you what's going to happen right now. There's going to be an error, and I want to show you why. Okay, take a look at this. I did not change anything. Let me highlight this and run. I expect to see an error message. Now, ask yourself why. What I just went over is that whenever you have an aggregate expression like here, like this in a query, every field that is not aggregate needs to be listed in a group by clause, right? Group by. Here it is. So I have to put it here. So this query is more informative because I'm going to know the average grade for each course. I want to know what the course is. And again, I keep getting more errors. And when it happens, what you need to do is you need to click on this error message, and you want to see this. You want to see what a problem is, right? An expression with course key is that, see this? It's because I'll show you what happens. Course key appears in two tables. It appears in the course table, and it also appears in the enrollment table. If in the select clause, if I'm taking the course key from enrollment table, I better take it from enrollment table here as well, right? So if you remember it, two tables have a course key field. In enrollment, it's a foreign key, right? So if I take this field from enrollment in a select clause, I have to take it in the same table in the group by clause. Let me run this. Now it should work. And I'm going to add this to the list. I'm going to add this to the script. So here, it makes more sense where I say that DBST 651 is an introductory database course, and 3 people took that course, and the course average is 84. And then I have a Data 610 course, the average is 88, and so on, right? And this is a distributed database and data warehousing. Those are most of the courses you see are DBST, but I'm just giving you the example, right? And as you can see, nobody took Data 650 course, but Data 650 course was one of the courses on my course list. So that's what I meant, that the relationship is 0 or many, because we have Data 620 that nobody took, right? We have Data 630 course that nobody took. And we may have some students who have not taken any courses. We would have to check. It's possible. Maybe the student was just enrolled. So here it is, and I'm going to save this query for you. Now, take a look at it. I kept on joining, right? And when you run when you keep on running queries against 2 or 3 tables a lot, right? It gets kind of complicated if you have to keep on writing the join. The queries can get really long. So what you could do instead is you could create a view. A view is a virtual table. It's not an actual table that's stored in the database, but what it does is it's basically like a virtual table. You don't need to repeatedly write a join. What you could do instead is you can write your query against the view. So here what I'm going to do is I'm going to join. Here I'm joining 3 tables: enrollment, and the student, and the course. And every time when you join the tables, you need to look at what columns the tables have in common. So here it is. This is my course and enrollment. One thing you guys do, it will help you if you print out the table name on the columns list on a piece of paper and highlight, use a different highlighter color or a different pen perhaps color, so that if you're looking at the course and enrollment, right, perhaps use one color to highlight the course key in the course table and the course key in enrollment table. Now here, as a student, you could use a different color, or you can use different line style, right, if you don't like the color. So student and student, right? We have to join tables on the columns that they have in common. Course, course, student, student, right? And what I'm doing, I'm using the alias, right? You have to prefix the column name with a table name, or you can just put an alias like this for the column. Keep in mind that for the alias, we cannot use the reserved words. So create is the reserved word, replace is the reserved word, right? Now, why am I doing create or replace? It's because if I already have a view with the same name, this will update the view definition. Some of you may have asked me that what happens if, look, for the table we drop and then create, right? Why don't we do the same with the view? We can, but the problem is if I have security defined in this view, if I have permission defined, like for instance, I want lineage to have a read-only permission, right? And I want Jerry to be able to access only the course title, and I don't want him to see the student's grade, right? It's just an example. So I define the permissions, and the problem is if I drop the view, when I create it again, I'll have to redefine all of my permissions, all of my security. On the other hand, if I do create or replace, all the permissions that I defined in the view, they stay, right? So now, another thing to keep in mind is that if I drop the enrollment table, my view will be invalid, right? So now let me run this, and this is gonna create a view. Another thing is, I wanted to show you that if you go here, if you go to the Explore database, and here it is, you can click on a view. Oops, you can ignore it. And again, I'm going to filter it. I want to see only, now here, I have to put the schema, and I'm gonna put my name, and that's my username. And I'm gonna do filter, and I'll show you something. I have two views in here. This view I called it academic. So when I click on it, it's gonna show me the properties here. And here, this is basically the view name and the schema, and the owner is me, the date when I created the view, and the date when I altered the view, right? So here it is, yeah. So now, what I do here, I click on columns, and here it's just telling me which columns my view has. And this is dependencies, this is important. Here it lists the tables that were used to create my view, right? So it's showing me that I used the student, course, and enrollment to build the view, right? So now, notice that here, if you click on expression, if you click on open in SQL editor, it will open the code to build the view in the SQL editor right here. So basically, in other words, I'm trying to say that the code to create the view is stored in a database, right? The code to create the view is stored in a database. So let me close this out, and I'm going to go back to my SQL editor. And next, I'm going to run a query against the view, and I'm going to show you something. It might be a little bit advanced, but it's something that could add value, so to speak. This is called a subquery. Subquery is a query within a query, right? So it's a nested query, and a subquery could appear in a select clause, in a from clause, and it could be in a where clause and in a having clause, right? So there are 4 locations in the query where you can have a subquery. So here, what I want to see is, I want to see who got the grade equal to or above an average per course. I'm not interested in the average grade overall, but I'm interested per course. So in general, if I take this piece right here, just this piece in isolation, right? And if I take out this where clause, right? If I take this out, and if I just put, if instead, look, this is what I'm gonna do right now. I'm gonna just put the course code, right here in the select clause, and I'll show you what this piece does, right? And now I'm gonna say group by, right? Course code. So this is going to give me the average, right, for each code, for each course. This is an average, right? So what I want to happen is that I want to list the students who got a grade above or below average. So basically for each course, I need some kind of like a lookup, right? Here I printed the average grade for all courses, but in this query, since each table row has a different course, right? I have to pass the course from the outer query in the inner query. Here it is. This is a subquery. I'm saying this. Here it is. Academics, right, is my view. Oh, I'm using the alias. I'm just or stands for the outer, basically. I wanted to use the word outer, but the problem is the word outer is a reserved word. And look, if I put this, if I type it, it's going to turn brown. So that's how I know that it's a reserved word. So here it is. What I'm doing here, I'm passing the course name from the outer query to this inner query, right? This is my inner query. And what it would help is that if you do the indentation, it's really helpful, readable. So this query returns the average grade for the course that you pass. And here, I'm just going to run this. And I'm going to know, I want to list the course, and I want to list the student key, and I want to list the grade. Notice that I did not put the names in here just to protect the student privacy, so to speak. So here, this student right here got a grade equal to or above average in data 610 course. So that's basically what it means, right? So you need a subquery here. This is the case when you use a subquery, right? So now I'm going to stop sharing. I'm going to go back to slides and show you a few more things in the slides, and then we're going to do questions. Now here, this is a query that I ran to check which tables I have, and I think this is important because, well, you can look at the interface, but I think it's more beneficial if you know how to do it programmatically, since you're not always going to have a nice interface for you. And here is another way to list all the tables, and I'm showing that I click on a funnel and I selected the schema name. Yeah, but keep in mind, you're not always going to have this interface. Now, here I summarized important key points about the insert statements. You want to make sure that you create all tables first. Do not mix insert and create table statement, right? So remember the terminology. Create table statement is data definition, DTL, and insert statements and select statements are called DML, data manipulation language, right? So we insert data into the parent table before child. Parent table is a course, right? And the student. Those are parents to the enrollment. Well, it's possible that we could have another table that has a foreign key reference in enrollment. Everything possible, right? So the same table can be a child to one table and parent to another. Now, each insert statement inserts only one row, and you want to make sure when you write insert statements, you want to make sure that the spelling is correct, because if I misspell my column, I'm going to get the error message. Now, and remember this, you want to, here's an example, you want to list in parentheses, you want to list the column names, right? So I put a graphic example for you to help you here. So see this, this is a table name, it goes on top. Insert into table name, and then in parentheses, I have to list all my columns and all the corresponding values. If you list the columns, trust me, although it looks like it's more typing, an extra minute of typing will save you half an hour on debugging the errors. Trust me. So this is a best practice. You want to list the columns. All right? So here it just basically saying that student key, it has to be an integer, and then the gender is a single character. See this? The reason insert statements are challenging because you need to pay attention to data types. So if gender is one character, and if I spell out female, it should give me an error, right? Because I allocated only one. and the admission year, and then I have the academic program. The limit is 20 characters, and here is just basically number of credits, right? Now, in theory, what I'm doing here, it's not good to store number of credits as a property of a student. It should be a calculated column. So another option was to add this column to a view where I would have to look at my enrollment, and I would have to take the sum of the credit hours of the courses that the student completed successfully, right? So you can have a calculated column in a view. That's another advantage of a view, take a note, because in a view you can have a calculated columns, and it's going to be updated automatically as the data is updated. So, yeah. Now, here you can just check the view properties like this, right? And here I just put an example of the subquery, and I put a link where you can get more examples of the subqueries, because, well, I decided to go over examples that are a little bit more challenging, right? Because most of you like challenge, I know that. Now, and here, this is a troubleshooting. So some of you received this error message, and I want to thank Jerry for posting this error message yesterday in a discussion, because I think this is very important to point out. So if you receive this error, credentials for Big SQL were earlier found to be invalid, it means that your session is timed out. And this is done for the security reason. If you are logged in and if you're not running any code for a while, your session will time out to get logged out. I'm not quite sure what the setting is on the Big SQL, but usually government databases, it's usually 15 minutes. So if you're not running any code for 15 minutes, when you return, you will have to log back in. That's what basically this error message means. So more likely you would need to relaunch the Big SQL, and it should do it. And again, this error message happens when I try to run the code, but I did not select my database. So you need to select your database if you see this error, right? I guess now it's time for questions and answers. So let's see what questions we have. How does loading data affect the code? May I ask you to elaborate, because, well, loading the data, you load the data via insert statements, right? So for each data row that you insert, let me share my screen. Okay, because I need to share the code here. So you load the data by insert statement. Each insert statement adds one row to your table. You're not loading it. You're not loading it the way you did it in the last assignment. You're writing it programmatically. So basically, an insert statement adds one row to the table, right? So that's what's happening. I'm not using the loader. I write one line of code to insert a single statement in this table row. I'm doing it programmatically, and I had to make up my data. I just made it up. I said, let's see, the first student is going to be a male, and that student is going to be admitted in 2006, and that student is a data analytics program, and that student completed 6 credits. So I'm writing this code. Can we quickly review saving work? Oh, yeah, excellent. So to save the work, yes. To save the work, this is what you do. Open up the notepad. Open the notepad. And whenever you get the working piece of code, you just copy paste in the notepad and send it in the local hard drive, okay? Well, because basically what happens here is that the code that I ran, it got saved. The code that I ran, right, the table that I created, it will be there. But for the script, you have several options. You can copy and paste the script to the text file on your local PC, or this is another option. Suppose that I take this, Control-A, Control-C, Control-A, Control-V. Look at it. What I did is, here is my script, right? and let me run it from scratch. I run it. I got this working nice script, right? So what you could do is, one option is take all the contents here, right? Take everything from the editor, right? Control A, Control C, right? This is how you would normally do. I believe in the Mac it's a Command C, something like that. And then I would go here on my notepad or text pad, I go File, New, and I paste it and I save it in the local hard drive. That's one option, right? So whenever you get something working, you want to save it, just in case if you get disconnected or anything like that. Now, this is another option that I coincidentally find out is that you can click on this. You can click and your code is going to be in here, this piece right here. So I click on it and here is my code that I ran. But you have to click on the top, and this is my code, this part. Another thing that I wanted to tell you is that you write your code today, there is a high chance that when you look at it 6 months down the road, you might not remember what the code does, so you need to add comments. And a comment, it starts with the dash dash, I believe, yes. Comment. So comment is a non-executable line of code, but it tells you what the code does, basically, right? It tells me what the code does. Like, see, here it is. Students with a course grade above class average, well, something like that. This line, it's not executable, but it tells me what this query does, right? So that I can refer to it later on. I hope I answered your question. If not, please let me know, because I call it customer service. Oh, all right. I'm glad to know that I answered the question, Jonathan. So, yeah, this is a good time for you guys to ask questions, right? So let's ask questions. Let me go ahead and check the chat to see if there's anything in the chat. Okay, okay. Is the commit statement necessary when adding? Yes, you need the commit after the last insert statement, because basically when you insert data in a table, it's actually not in a table itself yet. Well, it depends on a database property, I would say, because in some databases the setting is auto commit. When you set the setting to automatically commit, it's gonna write to database right away. But since you don't want to take chances, you never want to rely on the defaults, but always good to check. But here, let's look at the options. I don't see the options. I don't see the options in here. Okay. I don't see an options, but I do see other options, like when I put my cursor, remember it was running all statements. There is also an option to run the statements after the current cursor position. So this is an option here, right? And there are options to what to do if you, Oh, here it is. Look, automatically commit each statement. So that's good that I have this setting. Well, but having the setting on is good and bad. It's because sometimes when you make a mistake, if you actually don't want to commit, you can roll back. But if it's committed automatically, then that's it. Yeah. So let me look at additional questions. How loading data affects the code? Well, we discussed this one, right? So basically, you want to, here you're loading data programmatically. There is no interface. Unfortunately, no. So we went over saving the work. So we are only doing SQL. Yes. Yes. Is it good news? This assignment is only SQL. There is no R on this assignment. Good news, there is no R on this assignment. Bad news, there is no R assignment, because some of you might be better in R than in SQL. Well, Yelena is the opposite way, but some of you might be the other way around. Well, All right. So now, so we build the data tables first. Well, yes, first, that's a good question. First, we define the statement of work. What data we want to track, yes. Then we put the drop table statements on the top. Then we build our tables, and then we put insert statements, and then we query. That's a workflow, right? Well, unfortunately, we cannot load the data in a CSV. You have to write the insert statements. But I was just showing that for some reason it allows exporting it. When you run a select statement, when you run a query, for some reason it allows export the data that the query returns, but there'll be no CSV file. Here you just run insert statements to load the code. You do it programmatically here, one row at a time, right? So if you want to insert 100 rows, you have 100 insert statements. Well, that's not how you really would use in the real world. In the real world, for instance, if you use Oracle, you're going to do the SQL loader, right? And here, if we had access to the file system, we would use the loader. If we had access to the file system, we would have used the loader, right? But since that requires some programming and some scripted knowledge, we're not doing it. Now, I hope I answered the questions. Can you repeat? Oh, the workload. Oh, I mentioned it the workflow. Jerry, I mean this is a set of steps that we need to follow here, right? So first, we need to define the problems that we're going to solve, right? That's what I'm doing. That's what I did in the slides, right here. That's a workflow. Here it is. So I've got my problem that I defined and I was going to solve. And I said I want to track my student enrollments and want to track their grades and what courses they took, right? And how many credits they have completed. And here is the business problem. Now I want to identify, that's called an entity in the database terminology, student, course, and enrollment. And if you notice the database book, they suggest you to underline it. And then what you could do is you can circle the attributes, like what are characteristics of the student, the gender, right? And the academic program the student is in. Here I'm making an assumption. I assume that the student is enrolled in only one program. Because if a student could be enrolled in more than one program, I would need a separate table. I would need to have another table to track the student ID, the program name, the day when the student was admitted, right? And the number of credits for requirements to the graduation. Well, something like that. We can go in real depth in here. Now, I've got the course information, such as course title, and the number of credits that you earn upon completion. Then I have an enrollment, the actual grade record. And here, I'm tracking it as a numeric grade. I can even write more elaborate query where I want to display when I want to display the letter grade, right? So you would have to do something like a case statement inside in the select clause of the query. So you have this. Then this part, I just did it. I just did it for illustration purposes. You may have seen it in Data 620, I think, right? The entity relationship diagrams. So I'm just saying that an enrollment record, right? Each student may have more than one enrollment record, and you have more than one student enrolled in a course. And then here, I'm just summarizing the rules for you. Then I'm running the script to create my tables, and I'm inserting data, and then I'm running the queries against my data. And in the database live, the queries is going to be the reports, basically, right? So that's how it is. We create the database, we populate it with data, and then we run reports. And I create a view to simplify some of my queries that require joins, right? And another thing to keep in mind is that for most of the views, we cannot use the view to update the data, especially if the view has a grouping function or if the view has a join, that view cannot be used for the updating data, right? And the view does not take the space in the database because it's not a materialized view. There is a big difference. If you create a materialized view, then it does. But here, this view does not. And the updates are automatic, right? So secretly, when you run the code against the view, secretly, the definition to create the view runs behind the scene. See this? So basically, you have essentially the same query, but you don't need to worry in which table your data is stored. You just pull it from the view, right? So now, sources of ideas and business problems to solve. Well, I guess anything that you like. Pick something like your hobby. Like, for instance, if some of you like the baseball, you could track the scores, game scores, the player information, anything like that, right? Or if some of you like reading, you can track the books table, you can track the authors, and you can track which author wrote each book, or you can even do the book sale and add a store table. There is no, you can just think outside the box. Pick anything that you know about really well, right? We cannot update using big SQL, but we can achieve it by, well, yeah, no, you can. You can run update statements. Yes, you can run update statements. You can. Yes, you can. It's possible to update, all right? So let me do something this. Let's do this. Let's do this. Update enrollment. Update enrollment, and then I'm going to say set grade equals 100. Of course, the department chair is not going to like it, but let's do this. Oops. I'll tell you what happened. It's because I should have highlighted the queries that I wanted to run. I accidentally ran everything. I did not want to do that. But let me see what's going to happen now. Elena went so nice. Oops, it failed. It failed. I would have to look up the syntax. Okay, okay. Oh, it's because I see. I see. I see what the problem is. I see. It's because I misspelled, right? I have to put the correct table name. So let me see the correct table name. But yes, you can update. Yes, you can. You can run update statements, and you can do the delete statements. It's Yelena messed up the syntax, basically, enrollment, right? Here it is, yeah. But if you're not sure what the syntax is, see this? See this? But here, what they're doing is that they have a where clause. It's because they don't want to update every single row. See this? They only want to update the row that meets the specified condition, right? Yeah. Like this, yeah. And then you just run this. And we want to make sure that grade is one of the columns, yeah. Has to be, oops, it failed again. Oh, it's because, see this, I have a view, that's why. Oh, it's because I misspelled something, yeah. Yeah. But anyways, just keep in mind that it's possible. I would have to look at the set grade equals, let's try this. Well, anyhow, oops, I accidentally ran everything again. But what I want you to know that it's possible, and you have the syntax here, right? Here it is. Stock is one of the tables, and here is one of the columns, right? And they set it equals to the new value. And this is a where clause. It's a file where they want to do it. So it should work. In theory, it should work, right? So just keep in mind that in theory, it should work. Well, it failed. It's because my syntax is wrong. what I would have to do is I would have to look up the. I would have to look up the syntax. Or what I could also do is I could drop the view and see if it makes a difference too. Right? I could delete the view. To drop the view, see this drop? I could do that, but in theory you don't want this. The reason you don't drop the view is because when it's gone, you are deleting all permissions that were defined in the view, right? So you usually don't want to do it. You usually want to do create or replace. Oops, it still failed. I would have to look up the syntax. But in general, just so you know that yes, you can. Yes, you can do updates. You can. Okay? In general, you can. Yeah. I would have to look up the syntax again, but you know, this is how you do it. Upgrade and then update, update and then you put the table name and you put set and you put the column name equals and whatever you want it equal to. Right. Or I could try this. Set grade equals grade times 10. Well, I think I don't have a constraint in there, right? Do I have a constraint? Oops, I ran everything again. So what I should have done is I should have changed the property to run only the statement that follows the cursor. I should have done it. But, well, not a big issue. But I hope I answered the question. You can update, okay? In general, you can update. Okay, now let's see what else we have. All right, so go ahead and ask me more questions. I like questions, and especially the SQL. I love SQL. So what's most important is that you understand the concept because, well, like for instance, I have an idea of a concept of what update does, right? And then I can always look up the syntax, how to do it in big SQL. And with an update or delete, you make sure that you have a where clause. Otherwise, you could accidentally update the whole table, right? So for instance, if I wanted to give an A to Abel, right? I want to update only his grade. I don't want to update the whole class. I think you might be thinking would be nice, but no, TA does not do grades, unfortunately. All right. So let's see what other questions we have. I hope I did not bore you because I realize it's a lot of information. Stop sharing. So let's see what questions we have. I really like questions. Bianca, do you have any questions? No? Anybody? Jonathan? Keith? Peter? Ramya? Anybody? Okay. Linish, is there anything you would like to add to what I said?
No, I think you pretty much covered it all. Thank you.
Sure. So, anybody else has additional questions about the assignment or about anything that I just covered? I guess then we call it an evening, and good luck to everybody with an assignment. You can post the questions in a conference, and we're going to be paying attention to the conference over the weekend. And thank you, everybody.
Thank you, Elena. This was really good. Appreciate it.
Thank you. I'm stopping the
Thank you.
recording. Sure.